Hi, everybody, and welcome to another recorded Zoom interview. Look who we have here. It's a familiar face and a familiar voice coming at you in just a second. Dr. Basil Tikoff, University of Wisconsin. Basil, the weather report this morning from Madison, Wisconsin.
Well, it stopped snowing. We have about 8 inches on the ground,
Oh, wow.
and that was a little bit of a sludge coming in this morning, but we made
Okay.
it.
Thank you on a Sunday morning. Thank you, Basil, for that. That's old fashioned. I love that old timey, wholesome view of Wisconsin back in the Midwest back in the 70s for me. So it's still happening. The snow is still happening. Wonderful. Okay, too many words about the weather. Get off the weather, boy. Okay, here we go. Viewers, can I talk to you directly for just a second? Basil was a major player in what we were doing 3 winters ago and 4 winters ago. So if you're new to the channel, you're not familiar with Basil, but he has been a guiding light in many ways for what I've done with many of these alphabets. So I'm coming to Basil this morning. We're entering early December. We've done our 6 episodes in November, looking mostly at Bob Hildebrand's work, and I'm looking for places that I can go, things I can lean into a little harder, things that I might want to think about shifting focus. And the tone of this is warm and it's collaborative and it's constructive. And that's what we're going to do today. So Basil, can we start with what I think might be one of the most important sites in all of the American West, the Carmacks lavas. Do you agree that the Carmacks lavas in Yukon are important?
Yes, they're clearly important. The paleomag on them is really good, and there's very little geographic flexibility about where you're going to put a fault. It has to be the Tintina fault.
Okay. You have a new model, a hit and run model, a revised hit and run model from what you put out 30 years ago. Did you address the Carmacks at all with your new hit and run paper?
Right, and I have to give Bernie Housen credit here. So what Bernie did is he redid the paleomag and he looked at the new cratonic poles from North America.
Okay.
And so that revises the movement of the accreted terrains with respect to the North America, because North America can move north or south in addition to the accreted terrains moving north or south.
Okay.
When you do that, it turns out the Carmacks group is a little less movement than Randy Ankin had suggested using a different paleopole. And so the estimates are about, I think, 1,400 plus or minus 400 kilometers of movement. But the critical, which is a lot, right?
Yeah.
But the issue is that that's at 70 million years, right? So it's light, and you have to move the Carmacks. If you're moving Carmacks on the Tintina, you're moving everything to the west as well. And there's no way around that.
No way around it. And that is why I'm leaning harder and harder into the Carmacks, because I just feel like that's the place I start. Like, I think this might be the beginning of a number of visits I have with folks with different levels of expertise, geographic and everything else. I might start with the Carmacks with almost every person. Like, do you acknowledge that there's this major amount of so late and so far east? And to me, that's why it's such an important site. Okay, well, maybe we'll revisit that in a second. We've got a bunch of slides to look at and enjoy. The other thing I definitely want to touch on, and maybe you have some slides with this, Robert Hildebrand has the Blue Mountains in northeastern Oregon tied pretty carefully to the Belt Purcell in Montana and British Columbia, and those guys are joined at the hip. Do you see it that way before we go to some slides?
Yes. So I see it that way starting at about 90. So I would change the timing a little bit,
Okay.
what Bob suggested. But I mean, really, it doesn't matter for the purposes of what he's hypothesizing, because his slip hell has to be later than that anyway. But so yes, I think the Blue Mountains are basically attached to the Belt Purcell by 90 million years. And that's an undeformed pluton called the Paya River tonalite.
Oh, okay. I recognize that name from the Penrose conference a couple of years ago. Did we see it on that field trip?
Yes, we did see it.
Okay. Well,
Despite the what was it, the
oh, yeah.
crazy weather we were
Right,
having?
right.
But I can't
Okay.
even remember. There
Okay.
was some crazy weather.
So that was August of 2023, and yes, that Pat River tonalite that sticks in my craw. Okay, that's important as well. I think that's enough to set the tone for what we're wanting to do. Do you want to do any more like opening comments about? You have been watching the Alaska series. Thank you at 1.5 speed, by the way. So maybe I should start talking like a chipmunk, so I sound better for you.
The
Um,
students assure me that you don't talk like Chipmunk, and it's true. You do not. It keeps the tone very, very good. Uh, and so I
any,
do have one more thing I'd like to say.
sure.
So on the Tintina, there's a what the geologists have considered for a long time a good tie point that's 400 to 450 kilometers of right lateral slip.
Yeah.
So even on that simple system, right, one fault, paleomag, geology offset, there's actually a mismatch,
Okay.
and it's a mismatch of about whatever 1,000, maybe you know maybe everybody wants to push the paleomag to like the minimum, but the reality is the paleomag is in a Gaussian curve, and so the further you want to move it from that mean, the less and less likely it is to have moved that far. So
Okay.
if it's 1,400, it really is probably right around 1,400
Good. I love that.
kilometers. So anyway, there's about 1,000 kilometer mismatch.
Hmm.
So something's up even on a simple system like the Tintina.
Yeah. Yeah. Well, I have a whole new color scheme I'm going to unveil on Thursday, which is coloring faults by age, and we'll try to find some patterns that way. So I think that's my plan for this coming Thursday, December 4th. But who knows? You might drop some bombs here in the next half an hour or more, and we'll see where we go. So let's look at your first slide, Basil, and however you want to do this. And it can be far afield. I mean, as Basil struggles to share his screen, this is a guy who has expertise in Western Idaho with the Western Idaho Shear Zone. He's got expertise in the Sierra Nevada of California and other places as well. But those are his two money places for sure. And we'll see where we go. I have a full screen. We are enjoying it. We have a laser pointer, I'm sure. There it is. It's not red, but you're going to make it red. And we are all golden. The floor is yours.
Okay.
Thank you.
So these are from the Tikoff et al. 2023 paper, but they're really the work of Bernie Hausen.
Mm-hmm.
And I guess since we're starting with Carmax, there we are. That's where it sits.
Yep.
Then this is for about a 70 million year time frame. So the paleo pole is this way.
Yes.
So North America has actually been moving south from 100 to 70.
Mm-hmm.
Carmax is there, but the paleo mag has it here. So it's the current estimates, if you believe the North American only reference frame, which is what Bernie used,
Okay.
is it's hanging around somewhere in British Columbia territory
Okay.
at this time,
Huh.
right? Basically when it starts to
I see. Not south of the border.
it's not south of the border.
Yeah. Okay. All right.
And that's good because it would cause a huge space problem if it was. So it kind of works. You can still kind of squeeze it into this area.
Mm-hmm.
And I guess I wanted just to show also the age plot on the x-axis versus the amount of displacement, and there's Carmax. So the problem with the Carmax is it's light, right? Whereas all these other things, right? You actually can kind of track the northward motion,
right?
But then the Carmax comes in really young,
Yes,
with a lot of displacement.
Yes.
That's the issue with the Carmax.
So, do you agree, just verbally, that much of that Baja BC series, at least the first half, we seem to be looking so carefully at the boundary between insular and intermontane, and now suddenly we're east of intermontane with the Carmax? Are you looking east of the intermontane as well now, or do you still like major amounts of translation with your hit and run model between intermontane and insular?
I think there has to be major movement between insular what you also call Wrangell composite terrain.
Right.
That's what they're calling in Alaska.
Yeah.
And so between insular and intermontane terrain, there has to be a lot of slip. And in part, that's to get the insular super terrain up so it's adjacent. So I guess in my model, Nick, in my head, my mental model is that the insular hits, it starts moving north, and then the last 1,000 kilometers is piggybacked where it's then stuck to the intermontane, and then the slip goes on the east side of the intermontane.
Interesting. Yeah, that's
So it's sort
helpful.
of it's a whale at first, and then it becomes a mega whale for the last, 1,000, 1,400.
There we go. I like that. Thank you. Okay, please, wherever you want to go
Okay.
next.
Well, so if you do that,
Yeah.
there's lots of strikes of fault. It should be a no surprise that things are moving.
Mm-hmm.
But the one of the big ones has to be the Titina.
Yeah.
The Denali is moving, but the Denali is going to could potentially move the insular superterrain up,
Yes.
depends exactly how you connect it, but it's not going to be able to deal with the Carmax group
Okay.
itself.
Right.
So you're kind of stuck. I mean, the only thing you can move it on here, and I should say that tie point here is basically a thrust fault system that seems to be on the west side and the east side. That's this 400 kilometers
Okay.
offset. So if you move this point back to here, you get certain amount of displacement,
Okay.
but and so forth. So I think Bob is right, and I think Randy Ankin before him was right that
Mm-hmm.
basically you've got to be putting things on the Tintina.
Mm-hmm.
The question is, what do you do after that, right? And so Bob suggests moving it right along the Rocky Mountain Trench. I think there's some issues with that. It can be right,
Mm-hmm.
right? I mean, the problem is we don't know.
Mm-hmm.
And so, like, any idea that's out there is a good idea because we can test it.
Good.
Another idea is to push it through the northern Rocky Mountain Trench potentially, and then basically push it into the hinterland zone through here. Because one of the problems is the Mount Tatlow um, paleomag study is actually on the east side of the Coast Plutonic Complex.
Mm-hmm.
And that's the one that's got the 3,000 kilometers of movement on it.
Mm-hmm.
That passes a fold test and is really good. So it's hard to not take this bit of real estate along. So it's unclear exactly how to run this thing up.
And there are some people who don't want to run the Tintina down to Sky Cooley's house in western Montana. They do want to veer it down towards Washington State.
Yes.
I see.
So right,
Yeah.
you either say it's all on the coast,
Mm-hmm.
but then you miss the Tadlow and the Turn Creek stuff,
Right.
or you say it's in the middle,
Mm-hmm.
and there's a lot of reasons it could be there. That's if you push me, that's where I would say it is. Or you run it down the Rocky Mountain Trench. But I think that's a kind of a minority
Yeah.
opinion. I think Bob is suggesting it, and it's good. I mean, it's good to have ideas, right? So
Right.
you can test these ideas.
I'm willing to guess that I'm sorry to cut you off. I'm willing to guess that you've got a few slides to talk about the reasons that you are thinking about bringing that Tintina down to Washington as opposed to Montana.
I do, and I wish I could be more positive. It's more that there's problems bringing it down the Rocky Mountain Trench. I mean, right? I would like to say, oh yeah, here's a great idea. This one might work too. But it's more why it doesn't work to bring it down the Rocky Mountain Trench.
Hey, can you stop your share for a sec?
Sure.
I don't know how much we want to do here, but can we just pull back for just a second? So
Sure.
you understand who I am and what I'm trying to do here, and I thank you for that. You keep watching, so clearly you see some value in this. What I'm trying to do is create this space where everybody can discuss their ideas, whether they're mainstream or not. And it's not peer reviewed. We're not rejecting anybody's premise or whatever. And I'm just hoping to have that spirit go through the whole series. Do you feel like you want to comment at all on, is that the reality with the rigid scientific approach to publishing papers and applying for grants and everything else? Like, just philosophically or sociologically, is what we're doing here totally different than what is done among people doing research in Western Cordillera tectonics?
Yeah, I think it is, Nick. I mean, you'd like it to be sort of more open, right? You want it to be sort of more like sharing of ideas, but there's a lot, it's a little bit more like junior high than you really would like it to be. There's a lot of posturing. There's a lot of, like people basing reputations on things.
Yes.
And then there's Bob, who's kind of outside the system, who can throw out these crazy ideas, which, and it's great, right? Because the thing is, you want new ideas, but
Yes.
you need them to be testable.
Right.
And so, insofar as that goes, that's what the scientists are looking for as well.
Well,
I remember somebody reviewed the proposal that was going to do the paleomag on Mount Tatlow.
okay.
And they said, I didn't believe the paleomag stuff, but I wanted to see what the paleomag would give us. And I was like, that's actually pretty great, right?
Yes.
That was somebody who was like, we need to know.
Let's do one more along this line, then we'll go back to the slides. Where are we with the paleomag? A generation ago, it was like we're going to attack the whole method. We're just going to ignore it because we don't believe the data. Is it still like that with a bunch of people working in the West?
Yeah, I would say so.
Jesus, really?
I think it's kind of changed a little bit, though. I think the resistance has softened. Let's
Okay.
put it that
All
way.
right.
I think there's some people who it's never going to happen. There,
Even young people?
I think the younger people are more amenable, and this is always how it is, right, to the new ideas. But like, there's a couple people who've told me they're like, I know I should think about this, but I just don't believe that you're going to do that, particularly with respect to California.
All
I
right.
just don't believe there's anything offshore California besides a subduction zone.
Okay.
And it's just like, and they're great because they actually come up to me and they say that, which means they're like, maybe in the most dire situations, you might be able to convince me
Okay.
that this is the case.
All right.
So,
Okay.
I don't know. The
Yeah.
other thing, and I want to say this,
Yeah.
is Karen Siglock changed the game. Because Karen Siglock, when she first published the data, she actually supported the shallow slab. So this is before the things you're talking about. But then, and when the 2013 paper comes out with Mitch Maholnick, that idea that you could use the slabs in a creative way is what broke the ice, I think. It's just like, because at that point, I was still thinking this has to be right. The paleomag has to be right. We have to make it work. But it was too hard to basically try and convince people of something. But having a new data set that basically said things are not what we seem was enough to sort of reinvigorate the debate.
Yes, but it
So,
feels like the tomography is the mantle tomography is in the same boat as paleomag. You think there's more traction with the mantle tomography than there is the paleomag with these discussions? You do.
yes, I think it's more that it's a consilience argument, right? That the two together are telling you something.
Huh.
And as soon as you add the fact that all the arcs are going into transpression at exactly the same time, it's all 100 million years, and they're all going to dextral transpression, and the arcs afterward look nothing like the arcs before. You've got three independent lines of evidence that say something's going on.
You're thoroughly wide awake now, everybody. Good job. All right, let's go back to the slides. Basil, gold, solid gold there. We're going to use that for sure.
Well, the other thing I'll say, Nick, is I think you're exactly right about. Can you see the
Not
screen
yet.
again?
No.
No. Here we go.
Got you flustered now. Yeah, got you fired
No,
up.
it's
You
all
can't
good.
even share your screen anymore. You're so fired up. In the
The
middle of
CarMax is exactly the right thing to do, I think, too, because one thing about it is it really links where you've been before
yes,
with where you're going.
totally.
Right? Because you can't get around that this stuff's going to move into Alaska, but you can't get around the fact it's going to restore down here.
Yes. Thank you.
Right.
Thank
So
you.
in some ways, it's exactly the right. It's a really good link, and it's a late link.
Thank you.
All right. So what I want to talk about is the Pelt Purcell.
Thank you.
And okay, I'm going to say this right now. I'm not an expert in the Belt Purcell, so I had to do a little bit of reading, more than I was used to thinking about. And so this is from Rich Gashnick. He did a nice field trip up there in 2024. And I thought this was a nice diagram to just say, oh yeah, here's the stratigraphy. We're going to need to worry about the Lemhi stuff. And so the question is, really, is this stuff moving north or not?
Yes.
right? That's what we need to know. And so the answer is, well, it's crazy talk to think about that it's moving north. But on the other hand, what the heck? Maybe it is. Maybe this is one of those cases where, like, something that we've thought about for sure is actually just not true.
Huh.
Right. And so it's good to sort of branch out and think about things. And this is what Bob's really good at. It's just like, stress testing these things and saying, is that true or not?
So you, Basil Tikoff, always viewed the belt as stationary and part of old North America, and recently you've started to change your tune on that. Is that true? And if so, who convinced you that it possibly might be moving north along with some other stuff?
Well, I think it would be Bob, right?
Okay,
And I think the point is that I'm willing to think about it
good.
because what's great about it is it's a testable hypothesis.
Mm-hmm.
And so, we can test it. But there's a couple reasons where I think even from the get-go, it's a little bit problematic,
Okay,
right? So it's not that I would say if you made me bet, I would say the slip is not here. But I'm willing to consider that the slip is here
okay,
and see how it goes.
okay.
Um, so let me tell you a couple reasons why I think you can't put slip um, basically up the thrust belt, which has to come out of Wyoming. And the idea is it would go around the thrust belt and move up
Okay.
north.
Yeah.
One of them is if you go east of the thrust belt. So place where there's really no thrust deformation, you get to the Little Belt Mountains.
Yes, that always comes up.
Right. And so now I'm going to go into this area in the next two slides and just blow up that area. So we're east of the thrust belt.
Yeah.
And now I have that was from Jim Sears.
Okay.
This is from Bob.
Okay.
It doesn't matter which geology you choose. I find Jim's just easier because Bob draws great maps. But the simplification actually helps here.
Mm-hmm.
The Little Belt Mountains, not surprisingly, have belt supergroup.
Okay.
And if the belt supergroup is there and it's on the other side of the thrust sheet,
Yeah.
it's really hard to get that as part of the moving zone. In other words, you're not over thrusting it, and therefore it's not from the south. It's always been the Belt Mountains have always been in Montana.
Because they're not physically connected to the belt that's to the west?
That's correct. It's not when Bob said Allochthonous in the belt that was in the thrust sheets.
Mm-hmm.
So that's one reason. But the other reason is it sits on pre-belt basement.
It does.
And that basement is Archean.
Okay.
And that Archean basement does not occur south of Idaho. If you go down into Yavapai, Mazatol areas, sort of Arizona, Colorado, Utah, that's all Proterozoic. It's not Archean. So whatever you do, you've got to get it onto Archean. I mean, it's a depositional contact on Archean.
Are you sure?
Yeah, I think people are pretty sure. Am I 100% sure? No, I have not stepped on those rocks. And I would want to step on those rocks to say I'm 100% sure.
But I mean, my without knowing a damn thing, I'm like, okay, we got a belt in those little islands. I want to connect it to the rest of the belt, and there's just been erosion to separate the little belts from the regular belt supergroup. And then if there's is there a base of the belt exposed with the main wad of it? And if there isn't, then that's our only look at the base of the belt is in the Little Belt Mountains?
No, there's other places you can see it, like up in the Panhandle. But the problem, okay, so let me get out of here and up to the Panhandle.
Yeah.
It's so metamorphosed up there that you're dealing with metamorphosed equivalent of belt rather than the nice Glacier National Park sedimentology looking ones. And that's what you see apparently in the Little Belt.
Okay. All
so it's possible that you could do it, but then you've got that little problem to deal with.
Okay.
Right. And I don't know where else you could take a fault east of the Little Belt, right? The idea is that the fault, if there is a major fault, it's basically in here, and then it's covered by these allochthonous sheets. And it's true that almost all the belt we see is in thrust sheets.
Mm-hmm. Mm-hmm.
So,
Okay, so there's
and
one reason that you want to swing the Tintina to Washington instead of down through here.
yeah,
Yeah.
exactly.
Okay.
All right. So that's one reason.
Okay.
All
This is good, of course. It's
right.
always good. Oh yeah. Nice.
And so I guess I wanted to say that when Bob in your show said, I'm not saying that Belt Purcell is
Exotic.
exotic. I'm saying
Yeah.
there's certainly a loftiness in large thrush sheets. All he's saying is basically these things are carried
Mm-hmm.
on thrush sheets. And so you don't know. And that's good, right? If they weren't carried on thrush sheets, we would never see them because they'd still be basically in the subsurface.
Yeah.
So,
Are we heading to the blues being tied to this belt stuff? And you definitely have major expertise there.
yeah, let's go there. I want to go one more place
Yeah.
before we get there.
Good.
So Bob has this idea that the Lewis and Clark line is cut off by a right lateral fault,
Mm-hmm.
and he's got about the right amount of slip on that.
Okay.
And so if you do that, so one of my difficulties with that is the Lewis and Clark line doesn't stop, right? The Lewis and Clark line, and this was recognized by King way back when,
Okay.
there's actually a whole series of left lateral faults here that are continuations of the left lateral fault on the Lewis and Clark line. So that is to say, structurally, the Lewis and Clark line just keeps going. And in fact, it's fascinating because these projections out basically bound the Rocky Mountains, the Black Hills, the Bighorn uplifts, the Beartooth uplifts are all immediately south of these big sinistral faults.
Huh.
So if you're pushing it, there's left lateral shearing on the I need to go back to laser pointer.
You're good.
If you're basically doing left lateral here,
Yeah.
the problem, and you want to cut it off, you've kind of got this problem of that there's actually the left lateral faults continue. So there's a structural barrier to doing that.
Why isn't there an offset at all of the Lewis and Clark line then? If it's an old structure and you need all sorts of translation to the north, why do we have a continuous line going all the way to the Dakotas?
Right. So the argument is then that there isn't a right lateral slip up the thrust belt. If there's no right lateral slip, it makes perfectly good sense.
Is there a chance that continuation of the Lewis and Clark going to the Dakotas is something else? Do we know the age of that?
It's possible. And Bader, who was at the North Dakota Geological Survey, looked at this and he said they look like they're following old Precambrian trends, right? And so it's no different from the trends you're thinking about for the Lewis and Clark line. Now, again, this is, you can argue about, kinematically, does it all add up? Is there enough slip on the Lewis and Clark line to also match this? And so forth. But I think there's a reasonably good argument that there's structural continuity here.
Maybe I should think more about the Lewis and Clark line as some sort of, whether it's offset like Bob wants it or not, north of the Lewis and Clark line, there's kind of a tidy story, I guess. Like we bring the Tintina down, maybe does the Denali fault go all the way to the Lewis and Clark line and then it gets cut off? Like basically, this problem of taking this Yukon and British Columbia story and get it down to the lower 48 is an issue for you and many in some respects. Is the Lewis and Clark line a major boundary that is separating a simple story to the north and a more complicated story to the south?
Yes, I would say that's exactly it. And King used the Lewis and Clark line to talk about the central part of the Cordilleran origin versus the northern part.
Yeah.
It is sufficiently big that it's actually the dividing line. And everything north looks more like Canada. Don't tell this to northern people in northern Montana, but geologically, they're really in Canada, right? It's part of the northern Cordillera. That's what that thrust belt system looks like. And it's probably a very different lithosphere up there that allows it to be more rigid. And instead, to the south, it does something else.
Where can I find the Lewis and Clark line in Washington? It's going right through my backyard, apparently.
Well, again, I think it's cut off. Um, I think it's cut off by a right. I would put the right leg
Oh,
over. So I would think I mean, it's truncated there. And the reason it's truncated is it never went into the accreted terrains. You're looking at what is this going to be, a Mesoproterozoic
oh, Jesus. Okay.
feature,
Oh, wow.
right? So the accreted terrains don't see this at
I
all.
see. Okay. Wow. Man. All right. I'm going to have to replay that. Keep going. I love
All right.
this.
So, well, no, let's do what you wanted to do, which is then go to Idaho, because again, I feel like I know something about
You
Idaho.
sure do.
Uh, so here we are. This is from the Busby et al. Paper. So here's the Blue Mountains that don't really look like the Klamath or the Western Belt. They're their own thing. They look a lot more like the intermontane terrain. They collide somewhere around 170. There's kind of big brackets on that. It could be 180, it could be 160. Um, and then they start rotating, but
Okay.
they're not, their position with respect to North America is not connected. So the question is, when do they connect?
Huh.
And so if you go to Idaho, here's these names you probably remember: Hazard Creek, Little Goose Creek,
Oh, yeah.
Payette River Tonalite.
Yeah. Yeah.
And so um, the Little Goose Creek is where the Western Idaho Shear Zone. So this black symbol is Western Idaho Shear Zone, which
Yeah.
extends from the Payette River Tonalite to the Hazard Creek.
Okay.
But when the Payette River Tonalite comes in, part of it is not solid state fabric. So it's not part of the Western Idaho Shear Zone. It's younger.
Okay.
And so that's the stitching pluton,
Hmm. At 90.
right? And we know the timing of it. It's 91
Okay.
MA.
So Bob was saying the Little Goose Creek ties the belt and the blues together. That's maybe a minor detail, or is it more
It's a
important?
minor detail.
Okay.
I would disagree because this is a shear zone,
Okay. All right.
right? And you can't, a stitching pluton has to be a not deformed thing. The Hazard Creek is, you cannot find undeformed Hazard Creek.
Sure. But this
So
is
it's
important
deformed.
from my point of view. This is important because you're agreeing with Bob Hildebrand that the Blue Mountains and those terrains are tied to the Belt Purcell because of this Payette River tonalite. And there is excellent paleomag on the Blue Mountains saying we've got more than 1,000 kilometers of movement north. So then suddenly we do have the belt going north 1,000 kilometers.
Well, you gotta be careful. There
Okay.
is good paleomag there, but it's not from the areas that are immediately adjacent. It's from the Mitchell Inlier.
Okay.
And the Mitchell Inlier is, well, if you know where Mitchell
Yeah.
is in Mitchell, Oregon, right? It's way west of this stuff.
Oh.
And so the question is, does that paleomag apply to the eastern part of the Blue Mountains?
Huh. And you say
And so
no.
I've talked with people like Becky Dorsey, who's worked a lot there, and it's like it's really hard to figure out where you would put a fault.
Hmm.
If you want to put a fault between,
Hmm.
let me go back, between sort of the Mitchell Inlier stuff here and this stuff,
I see.
but it's not the same. We don't have paleomag because we don't have the right age rocks
Yeah.
here,
So
right?
you've got a little bit of the blues going with the belt, but it's over on the east side, and the
And you
argument.
got a lot of Columbia River basalts.
Yeah, those damn basalts. Right. Uh, um, is there more here, or can I ask something else about the blues?
I want to do one more thing
Yeah.
about
Go ahead.
so you go to the Payette River tonalite.
Right.
And so we did a study. We've sampled so much of the Western Idaho shear zone for paleomag,
Yes.
and only one place worked,
Okay.
but it was on the Payette River tonalite,
Hmm.
an equivalent thing. So this
Okay.
is Orofino. This is the 90-degree banded Orofino, the Western Idaho shear zone. We were just down here in McCall.
Right.
And what we noticed is that really geomagnetic pole should be this way.
Mm-hmm.
Instead, everything seems to be rotated. So we were very happy to say, okay, there's a rotation story.
Mm-hmm.
But what we never played is the fact that if it is next to North America, we would expect about a 71-degree inclination. So
Yeah.
the declination's off, right? The compass directions,
Yes.
but the inclination, which gives you paleo latitude,
Right.
is about on. I mean, there's slop here, and it's because there's a bunch of faults moving this stuff, but they're pretty steep. They're basically right in the range of this of what you would expect. And so it's not to say, and these are on igneous rocks for which there's no paleohorizontal. So they're not great, not great indicators. That's not why we drilled them for this. But the data we have suggests that it's pretty similar to as if it was on North America.
I'm starting to lose you just a little bit. So let me try to rephrase and see if this helps me. You showed up 25 years ago in Western Idaho looking for a major Baja BC fault, and you assumed that everything to the east of that fault was old North America, and there wasn't going to be a bunch of translation to the north. And so you're going to look for this stuff that's wildly moving north to the west of the boundary, but to the east of the boundary, you assumed there wasn't much at all. And Hildebrand is saying, look, both east and west of this line, everything's going north 1,400 kilometers. What does this 71 degrees, can you place that discussion you just said into that framework, please?
Perfect. So then we drilled PaleoMag, and it was different from what we would expect if it was on North America. It's rotated.
Okay.
Which was so weird.
Yeah.
That I just didn't do anything with it for 5 years while we tried to figure it out. Okay. But when I revisited it for this, I mean, I remember thinking it at the time that I had to resurrect that, is it's like it's rotated, but it's not translated.
Okay.
It's not moved north because, again, there's a lot of slop in the data.
Got it. Okay.
But I will say that Bernie Housen and I have a project, and you've met Ellen Nelson.
Yes.
She's doing this for her work, for her PhD. Good. And George Meyer, working with Bernie, is doing this, is they're looking at bedded sedimentary rocks that occur in the thrust belt.
Oh.
That are the right age. They're 100, they're 80, there's a whole range, and then because they're bedded, you can untilt them.
Okay.
And they've got PaleoMag data from these rocks. So they're actually going to, because they're testing this rotation hypothesis,
right,
they are inherently going to test Bob's hypothesis.
Good.
So you're actually going to, if you want to talk to Ellen in about 2 months, she would tell you basically what the paleo latitude is for that stuff.
Excellent. I love that. And she's so good. I'd love to get her on. Let's move on. Can we go to the map with blues? And if we can go back to that map with we can just do it this way. So you're the guy in the custom slideshow. Thank you for doing that. That was the first custom slideshow for our community, and Bob has taken that and run with it and made a bunch of his slideshows, and that worked beautifully. So thanks, Basil, for getting that going in your own way. In that slideshow, one of the highlights for me was you kept talking about the rocks in the Western Idaho area as being exactly the same as the Sierra Nevada. Can you remind me which rocks you're talking about, and then why on that map we just looked at are the blues so different than the Sierra? Or am I already making a mistake? You're not talking about the blues. You're talking about the stuff in Western Idaho.
Right. I'm talking about the magmatic arc.
Okay.
Okay. Let's see. Right. We'll go to this one.
Caught myself in the middle of that question. Yeah. Okay.
Well, that's okay. It's all good.
Yeah.
So the Western Idaho shear zone basically is here, and it starts at about 100 million years, right? So Claire Harrigan, working with Mark Schmitz, has done a really nice job dating titanite to figure out when it started.
Okay.
But if you go to the Sierra Nevada has a bunch of right lateral strike slip faults. The oldest of which is the Courtright, which runs basically is parallel to the batholith, and it runs about right there. And it starts at, wait for it, 100 million years, right? Good. And it's intruded by younger magma, so you don't see it everywhere, but you see it. It comes up as the Kaiser Peak, which is the same time, and so forth. So you see the switch to transpression at 100. And if I gave you a rock from the Western Idaho shear zone and I gave you a rock from the Courtright, you could not tell them apart.
Okay, see, I love that, I'm just looking for natural matches. If we're back to that concept, now we're not talking about a strike slip fault. I don't think that's separating the two, but we've got two pink sausages there that we're linking up and saying they're the same thing, Western Idaho and Eastern California. Then my mind goes to everybody keeps saying that the Klamath and the Sierra, at least that striped black and green stripe thing, were together until 140 and then they break apart. So do you agree with both of those statements that I just said?
Yes.
Okay. And the blues are they're a totally different animal.
They're totally different animals.
Can I match the blues with anything in Alaska or British Columbia?
Yes, I think the blues are intermontane. They're a little bit of the intermontane that gets stuck in this corner and it wants to get out. You can see it's trying to get out, it's rotating itself out to try and catch up with its brethren to the north.
Good.
But it can't do it. It got stuck in that trap at Orofino.
That sounds familiar. That's the hit and run model. Okay, good. Keep going.
But it's the hit and run model. It's okay. Let me try this.
I love it.
Which is that what really has changed my mind fundamentally is this realization that the North America itself is segmented, right?
Yes.
And so why is the Klamaths are so weird,
right?
Because they're the sticking out part.
Yeah.
The Klamaths were about there.
Okay.
And the Klamaths have moved north, and the Sierra has moved, the Sierra terrains have moved north with them. Because remember, we have a shear zone in the middle of the batholith. That shear zone has moved Western California about 400 kilometers with respect to Eastern California.
Okay.
Right? That's just making estimates of what the shear zone is doing through time. The point being, anything that's moving south is going to whap on that corner.
Yeah.
Right? And that's why the Klamaths are a train wreck, because everything comes in and it knocks on that corner.
This is coming back to me, and eventually I'm landing at the Talkeetna Arc, which is way older than 150, I guess. And so suddenly we are dealing with this left lateral business.
That's right. And the other place it gets trapped is up here.
Oh, boy.
Right? It's a huge place where it's going to get trapped. So when Bob says there's big thrusting there, it's like, yeah, there is, because the whole intermontane is trying to move south.
Oh, wow. Okay.
Right? And it's going to get stuck in these places. And that's why the intermontane never gets further south than about northern Nevada.
Okay, I'm going to go too far right now, but let's try it anyway. I'm looking at this map, and I'm seeing all this dark gray, Laurentia. And so is it unfair to say you are biased to major amounts of northward movement over in the white and not in the dark gray? And it just goes against some of your instincts to have major structures through that gray thing, which might be stubborn?
Absolutely. Right. And it's because I've been trying to figure out this 9-degree bend in Idaho, and it just keeps sticking around. There's something about that it would rather rotate than break through as a fault, which is crazy. Like, I have no idea why it would do that. So yes, my bias is that North America has a boundary which explains a lot if you're trying to move terrains up and down. And so I want to always put slip in the white in the accreted terrains, because these are lithospheres that already have sutures where it's easy to reactivate them.
And so you're fine with the Tintina doing major amounts of motion and the Carmex because it's out in the white, baby. It's not in the gray.
Part of it's in the white, and then yes, it's out in the white.
Still, it's in the white, yeah.
So, but the one thing I do want to say is, and Randy Ankin said this in your video, it's remained one of my favorite parts of this whole series. Like, I'm not afraid of data.
Right.
Bring it on.
Yes.
If I'm wrong, that's awesome. I have been wrong before, right? I thought this whiz was always north-south and always been north-south.
Yes.
And I was just wrong.
Right. Well,
right? And so if there's new data that contradicts it, that's what science is. It's basically trying to figure out where we're wrong and why we're wrong so we don't make that same mistake.
well, I like this just instinctively in the moment. I don't know how long I'll stick with it, but yeah, Alaska's entirely white. British Columbia is entirely white. Like, are we really bold enough to do some major stories in the dark gray? Are we just we need to major amounts of convincing to go into that dark gray. Otherwise, we stay out of there unless there's compelling arguments, and that's maybe one of the major things that Bob's up against. I don't know. You had a game you had in mind. Do you want to go to a game?
Oh yeah, I do have a game. I do have a game.
Okay.
Hold on.
Oh, this is
All right,
fun.
you can play the game show here on Sunday
Yeah,
morning.
that's right.
All right, here's my game.
Oh boy.
I kept all the names. Don't look at the names.
Okay.
This is just an area of the world, and you need to put a big strike slip fault here.
Mm.
This is an aeromag anomaly map.
Mm-hmm.
And we can play the same game, but it's a less fun game with the gravity.
Okay.
Just to let that on.
Yeah.
Where's the fault?
On the left half, that's a northwest-southeast trending deal.
This thing.
Yeah.
Yeah, that's an obvious feature, right?
It seems to me, yes.
Yeah, okay. Where else are you going to put a fault?
Uh,
So we don't have any, it'd be great if we had a northwest, southeast running major Baja BC fault, but we don't. A major sort of terrain translation
we
fault.
have the owl.
Yeah, we do.
Okay.
Yes, we do.
I guess connecting the dots of the pink blobs in the upper left to the middle of the area.
Hit down to here.
Yeah.
Yeah,
Okay.
that's pretty good, right?
Seems like it. I don't really know what I'm looking at, but I'm just connecting patterns or connecting dots to make a pattern. You're wanting me to say something else, though, I think.
No,
Okay.
it's right.
I see my mother never loved me. That's a Rorschach test. Okay, go ahead.
Well, right, and then so the problem is, yeah, okay, and then we'll go here.
Okay.
So this is now gravity anomaly maps.
Mm-hmm. Same question. Where do I see a fault?
Yeah, same question.
I don't think I see a fault here.
There you go. There's both of them together.
Huh.
Same area.
Okay.
All right, so I'll show you how the geophysicist interpreted this.
Okay. Oh, God.
Right? So you can see the whiz
Huh.
because my eye, of course, just gets drawn to that, but that's what that is.
Okay.
Here's Wyoming Craton, or what they think is Wyoming Craton. Here's this trans-Montana belt, and then there's this Great Falls tectonic zone in here, and then there's the trans-Hudson orogeny here. So the point is, between the whiz and proper Wyoming Craton, you need to run a fault, right? This is what Bob wants. And the thing about the geophysics is it kind of averages the crust a little bit, right? It's not just an individual feature, it's the average of the crust. And so the question is, can you reasonably, with geophysical anomalies, run a fault anywhere?
Yeah.
Right? If you run it basically north-south up the edge of Wyoming, which is where the thrust belt, and approximately, right? It's really hard. There's good continuity of the Wyoming Craton, and there's reasonable continuity of this, trans-Montana fold and thrust belt. And so it's hard to basically put something in there.
Okay, here's what's going on in my head. Excitement to learn new things with you, also disappointment, because I was loving the orphaned Omanika belonging down there in connected to Utah, essentially. And did the Canadian Rockies form in Nevada? And this is a bummer to see an image like this and not see any hint of that structure that's going to make the Almanica orphaned. Now, is this the wrong image to look at? Or would there be an image at some depth or some technique besides paleomag that could back up what I want to see here.
Well, this isn't going to help you,
Okay.
but this is from Rich, and he's using now detrital zircons and granites,
Okay.
where he can recognize that there's different provinces.
Yeah.
And so this Great Falls tectonic zone is younger than the Wyoming Craton, and he
God.
follows that trend right across the Idaho batholith, right up to the Whiz, and then it dies. That trend just totally dies, right? But you can see Archean zircons in the south part of the Idaho batholith, but not in the middle part. So the idea is that the Great Falls tectonic zone, basically the idea is that the geophysics and the geochemistry are agreeing. And this is exactly what you were asking for. Can I get something that's sampling deep and bringing it up?
Yeah.
Well, that's exactly what the granites are doing.
So old here. Yeah. Jesus. Okay. Yeah.
So again, it's not to say it can't happen, but there's just lots of evidence.
Right. Right. Um, you're coming through yet again, of course. Is there one main discussion area to go, or a couple of them? Are you wanting to go to the Sierra? Are you wanting to go? Where else do you feel like you want to go, or is this a nice place to stop? Maybe we can get you back on, and I don't know. Every month we have you come back on and react to what we're doing. I don't know.
Nick, I'm happy to do whatever works for you. I think this is great. I'm hoping to learn a whole lot about Alaskan geology, watching it. And I like the idea of just, being open. Like, we don't know what's going on. But what's great is we have testable ideas. And it's kind of a weird coincidence that we have a group that's, has the results. They just haven't analyzed them yet to say, could this be true? Because it's worth looking at crazy ideas because it's been a problem. I mean, Bob is exactly right. The translation's been a problem for a long time.
Yes.
And this is a really interesting way. And we've been wrong about other things. So why not try this one?
Let's do one more. Thank you for that. Let's do one more before we quit. I think you're the guy that said this. Maybe this summer I was like emailing folks, talking to folks in person, saying, I think I'm going to do Alaska A to Z. And they're like, oh boy, you're going to get overwhelmed. I mean, you can try it, but I think there's just so much. You're going to be paralyzed with all these places and everything else. And I think it was you, Basil, that said something similar, like Alaska's kind of a totally different animal. Like, and maybe I was saying something like, I'm hoping to take stuff down here and just connect it up there. And I think your main message was it's kind of a totally different animal up there. Do you still, after 6 episodes and other conversations maybe you've had, do you still see it that way? Or do you think Alaska is old friends from down here that are up there?
Oh, that's an interesting question. This is more of the sociology of science rather than science, probably.
Right.
It's got to be the same types of phenomena that are going on, but up there you're not dealing with a craton, right? You don't have the Archean up there. It's
white up there. Yeah, it's the Great
it's
White
just
North.
like one thing accretes. You also have the opening of the orocline, but then there's also just the names, right? There are people who work in Alaska, and that's where they work, and then there's people who don't, and then there's a couple people who kind of have one study there and do something else somewhere else. But the people who've worked in Alaska, they seem to. There's something about it that draws them in and keeps them there, and it's hard for us, the rest of us who don't work there, to like keep track. Maybe it's just the place names. It's just so hard to, I know Alaska, Anchorage and Juneau are, and, Nome, and I know the Brooks Range, but it's just like, it's hard to keep track of, all the other little bits and pieces. And without that, it's kind of hard to keep track.
It makes more sense now with you fleshing that out, and it's sociologically as well as geologically. It's a different world up there. And that's why I was attracted to Bob Hildebrand's work, because he's clearly showing the physical connection. And I think I'll leave you with a thought that I have. I don't know how serious I am. I think I want to make a map of the state of Alaska with that part's Washington, that part's Idaho, that part's California, that part's southern BC. Like if we can come up with a narrative where we can convince ourselves there's certain amounts of translation here and there, that it truly is a piece of this and a piece of that and a piece of that. And if that's the goal, to try to kind of get rid of all those foreign names and get familiar pieces of our real estate from down here up there, that would be pleasing to try to do that. Whether we have a major fault going through the Rockies of Montana, or whether we have it in Washington or even further west. So I'm going to put you on the spot. Next time we visit, maybe we can talk about magmas, talk about California, deal with Sierra Nevada, unless you want to toss that in right at the end. But I think this is a nice natural place to stop.
I agree. So, Nick, your idea is great. The problem is, what is British Columbia when, right? British Columbia is like the path-through zone, right? Everything goes through everything's British Columbia in that sense, right? Because it all goes through there. The question is, when did these different things go through? And that's also a major part of the Alaska issue. Is they're in extension at 100, we're in contraction, then they're in,
Right.
They don't get this major shortening until 85, where we're basically done with like the first phase of the major shortening. So there's this gaps in time where the times don't sync up.
Right. Run into that with Trevor for sure.
Right, exactly. And we're all trying to be like, well, maybe it. So
right.
I think the geometries might not be known. But so I think it'd be great to sort of figure out what is where when, and just come up with like reasonable hypotheses of, where's the map at 70? Where's Carmax at 70 is sort of what you might be able to do.
I think we're going to try that. Dr. Basil Tikoff, University of Wisconsin in Madison. Thank you for your time today. Hold the line. I'm going to stop the recording. We can chat for a couple more minutes before you're on to your next meeting on a Sunday. Thank you, Basil, for your time today.